Hi everyone. We will start with the last derivation we have left here. So this equation, whatever we have got, this was the earlier equation from the third video. So I had stopped here. That is, we got n divided by n minus 1, p1 v1, p2 by p1 raised to n minus 1 divided by n plus p3 by p2 raised to n minus 1 divided by n minus 2. Here I had got stopped here. Now we will continue with this. See, to get the maximum work, what we need to do, differentiate the work done equation and with respect to intermediate pressure P2. End conditions are remaining same, intermediate pressure is going to vary. So intermediate pressure, with respect to that, we will differentiate the equation. So if we differentiate the equation, see here, differentiation of this one P2 here in this condition, one step by step here differentiation has been done. So here P2 by P1 raised to n minus 1 divided by n is there. So differentiating of this one by P1 raised to remains same, differentiation of P2 is done here, and in this equation P3 raised to n minus 1 by n is common, and differentiation of this 1 by P2 is done here. So this step by step you just go on solving. At the end what we will get is this is the optimum pressure. Sometimes in the exam he will ask you to derive the optimum pressure or intermediate pressure equation. So intermediate pressure is always square root of product of final and initial pressure. That is, P2 is root of P1 into P3. So this one I can write like this also, P2 square is equal to P1 P3, and this in this fashion also I can write this. So this is very important derivation. Up to here also he may ask the derivation. Now the for two-stage compression with perfect intercooling, we will see the work done equation. This one was the equation which we had got earlier. Now we have one more, this one, these terms. Now we will substitute these terms here and we will simplify the equation. Now for two-stage, this is the equation we have already, but perfect intercooling is this one. I told you P2 is equal to root of P3 and P1, and similarly I can write this in this fashion also. So here P3 by P2 is equal to what? P2 by P1. So I will substitute this P3 by P2 raised to n minus 1 divided by n. Here I will substitute, instead of P3 by P2 I substitute P2 by P1. So these two are same now. So these two are same means this will add and it will become 2 times the P2 by P1 raised to n minus n divided by n. So here also 2 it is, here also 2. I will take this 2 outside. For two stage, 2 here it will be 2, and here P1 V1 raised to P2 by P1 raised to n minus 1 divided by n minus 1. So this is the equation you will get for 2. Now further simplification we will do that. P2 is equal to, I can write like this also, I said root of P1 into P3. So P1 by P3 raised to half I can write. So here earlier it was P2, I'll write this equation, and if I want to cancel this, I should take this P1 outside. If I take this P1 outside, already it is root, I should take outside as P1 square. So if I take P1 square outside, this P1 cancels, and here it will be it will remain as P1, and here I can simplify like this. So it becomes this half I am taking above, and it is becoming n minus 1 divided by 2n. So if I simplify, it will become P3 by P1 raised to n minus 1 divided by 2n. Just try to simplify this. Similar, this is the final equation for the two stage. Wherever 2 is there, here you should pick issue. If it is like this, it is two stage. If I substitute 3 here and 3 here, it will become for 3 stage, but pressure ratio should be initial minus final. If it is 3 stage, P4 by P1. If it is 5 stage, P5 by P1, but here it should be 4 and 4. So if I calculate for 3 stage, 3n, whatever here it was 2n, it is 3n, n minus 1, P1, V1. If it is 3 stage, it will be P4 by P1 raised to n minus 1 divided by 3n minus 1. So similarly for n stages, it becomes n, if it is 3 stage, n stage, and here n 3n, here it is capital N into small n, and here pressure ratio Pn plus 1 divided by P1. So this is the final equation for n stage. If it is asked for derive the work done for n number of stages, then you need to derive up to this much. This is also asked to determine the intermediate pressure of a X stage, theory part. So this derivation in combination with the steam nozzle problem, if it is asked, you should get 20 marks. So theory part of this video, this air compressor chapter is over. So you need to study the theory part. Problems I will solve in the next videos. Thank you.